Hello everyone, this is JT and welcome back to JT Fun Math. Today we'll be looking at the binomial theorem. So what is the binomial theorem? Well, the binomial theorem is a theorem that helps us to easily expand a plus b to the power of n. And this is the binomial theorem. So the binomial theorem states that a plus b to the power of n is equal to sigma, or the sum of k equals 0 to n of these terms. And the terms are n choose k multiplied by a to the power of n minus k multiplied by b to the power of k. Whoa, this is a big equation. And that's why we'll be splitting it into two smaller parts so that we can fully understand this theorem better. So today we'll be looking at the exponents and the coefficients. So firstly, I'll need to explain what a binomial is. A binomial is a polynomial that has two terms. And a polynomial can have constants, variables, and exponents. So now that we know what a binomial is, let's go on to our first part, the exponents of a plus b to the power of n, where n can be any number. So to look at this, let's look at a few examples where n is equal to 0, 1, 2, and 3. A plus b to the power of 0 is equal to 1. A plus b to the power of 1 is equal to a plus b. A plus b to the power of 2 is a squared plus 2ab plus b squared. And a plus b to the power of 3 is a cubed plus 3a squared b plus 3ab squared plus b cubed. So what is over here exactly? There's a hidden pattern in these sequences. However, writing it like this is not that clear. So to find out the pattern behind this, let's look at the last example here, a plus b to the power of 3. So I have rewritten it again in the form of a to the power of 3 times b to the power of 0 plus 3a squared b plus 3ab squared plus a to the power of 0 times a to the b to the power of 3. So now look at the blue boxes over here and look at the exponents of a. Over here, the exponent of a is 3, 2, 1, and 0. So now let's look at the second row, which has the exact same a plus b to the power of 3, but expanded. However, now let's look at the red boxes. These show the exponents of b, 0, 1, 2, and 3. So now let's draw a small table here to better understand this. So k equals 0, k equals 1, k equals 2, k equals 3. And take note that k are all the values from 0 up to n. In this case, n is 3, so we stop at 3. So firstly, let's look at the exponents of a. When k is equal to 0, the exponent of a is 3. When k equals 1, exponent of a is 2. When k equals 2, it is 1. When k equals 3, it's 0. So now let's also write it down for the exponents of b. So from this table over here, we can make a small expression to find the exponent of a plus b to the power of n. And that expression is a to the power of n minus k times b to the power of k. So now that we have this expression, we have completed the first part, which is the exponents of a plus b to the power of n. So now we'll be going on to the coefficients, because if you have noticed, having the exponents of the variables is not enough, because there are all these numbers over here, which are the coefficients. So to find the coefficient, let me write all this again in a pyramid form. So if you have noticed, I've also written all the coefficients of the terms over here. And the next thing that you can notice is, if I circle all the coefficients, it forms a special kind of pyramid known as Pascal's triangle. But how do we use the Pascal's triangle to find the coefficients then? So let me rewrite the Pascal's triangle in the form of n choose k. And take note, each one of these corresponds to the value at the exact same position of the Pascal's triangle. And we can continue to go on in this manner. And take note, n choose k can be written in this form or this form. And you can find it out by doing n factorial over k factorial multiplied by n minus k factorial. And this is to show the total number of combinations. So now that we know this, we can use this to find out the coefficients of all the terms. So now that we know this, and our sigma over here, which I have explained previously, we can find out the sum of all these terms to add them up to get a plus b to the power of n. And that's why our binomial theorem is a plus b to the power of n is equal to sigma k equals 0 until n, and the total sum of n choose k multiplied by a to the power of n minus k multiplied by b to the power of k. So now let's use a short example to show how the binomial theorem would work. So let's say we would like to find out what a plus b to the power of 3 is, and we would like to expand it. So we can use the binomial theorem to do this faster and easier. So a plus b to the power of 3, and in this case n is 3. So firstly, we take 3 and we take k as 0 because following the sigma notation, it shows that we start from 0 to n. So first, we'll start with k equals 0. And then this is our first term. Then we'll go on to our second term with k equals 1. That's our second term. That's our third term. And this is our final term. So now we can add them all up. And we'll realize that this is exactly the same as what we'll get if we manually expanded it. However, this is an easier method for us to expand a plus b to the power of 3. So now that we also have an example over here and explaining the different parts of the binomial theorem and how it works, I hope that you have learned more through this episode. Until next time, have fun in math. This is JT signing off.